shown in the diagram itself, we have the smooth surface and rough surface. Such a way that the smooth surface further divided into two cases: when block is coming in the downward direction, block is going in upward direction, and a rough surface, block is coming along the inclined direction and block is moved up along the inclined direction. In the semi condition, the first part will be the smooth surface and remaining part will be a rough surface. So in all these conditions, how can we calculate the particular concepts and time period and something they will try to ask you in the question. Okay, so how to compute each and every term, let us see in the shortest way. Okay, now in this particular case, first case, in the smooth down case, first of all let us try to resolve the possible vectors. Okay, so first of all we will try to prepare coordinate system first. Let us consider these are the coordinates, and we would like to fix this one for all the position of objects like this. So in this particular condition, these particular things will represent x-axis, y-axis, and as well as z-axis. Right. Now in all cases, we have vertical in the downward direction this particular component of force called as gravitation force mg, and in all cases standardly we have mg like this. This is mg. Standardly vertically down we have the force of mg in all cases. Upon resolving this particular mg into components, we have, upon resolving, these are the perpendicular components we have. So here theta means here also we have the angle of theta degrees, and hence in the downward direction we have mg sine theta, and along in this direction we have mg cos theta. Now inclined in the vertical upward direction we have the normal reaction n. So we can apply the same situation in all cases. So in all cases inclined down we have mg sine theta component, and the normal reaction n is equal to mg cos theta component. So I'm just preparing the thing. This is normal reaction, and in this direction we have mg cos theta because their inclination is theta degrees, and further in the downward direction we have mg sine theta. So all these resolutions are standard resolutions. Mg sine theta, so this is called as normal reaction. Along this direction we have mg cos theta, here angle is theta degrees. So inclined down we have mg sine theta in the last case also, and here we have mg cos theta, and this direction is called as normal reaction n. All these are all the standard resolutions. Okay, now at this particular case, so when we try to calculate the concept of a force, okay, so in this downward direction the total force acting on the system is given by FL is equal to, simply we can write down as mg sine theta, we can write down, where dividing by mass on both sides we have acceleration of system is given by A is equal to, we can write down as g sine theta, we can write down in this particular condition. Next, let us consider upward direction. In the upward direction, block is going in upward direction, and in the downward direction we have mg sine theta. Against the gravity it is going against the gravity, therefore along the inclined length the net value you can take it as FR or FL, you can take, no problem, which is given by minus mg sine theta, we can write down as, whereas acceleration is equal to minus g sine theta, we can write down in this particular case. Now in this particular condition on the rough surface, when block is coming in the downward direction, very interesting thing, when block is coming in the downward direction, the frictional forces acts along upward direction like this, Fk. By using Newton's second law here, net force Ma is equal to net force MA is equal to what we write down? Simply MA is equal to which one is dominating right now? Gravitation force is dominating. That's why it's coming in downward direction. Therefore, what we write down here? Mg sine theta minus Fk we can write down. Therefore, upon calculating M, we have G of sine theta minus mu k cos theta we can write down. In this case, net acceleration in the upward direction. So, frictional forces also added here. Therefore, acceleration of system A is given by G of sine theta plus mu k cos theta we can write down here. We will see this particular entire case at the last of the entire explanation. Okay. Now, after completion of this, very important thing and interesting concept, that is so how can we find out further information in this particular case? Let us see. Whenever you have acceleration like this, what is see, initially releases means u is equal to 0 we have to take. When you consider u is equal to 0 in this case, what is the final velocity? Upon reaching the bottom we have to calculate. So final velocity, we are using third equation of motion by substituting acceleration a is equal to g sin theta in the third equation of motion with u is equal to 0. We have the final velocity v is equal to root of 2gl sin theta we can write down, and further time of journey is given by speed by acceleration. So v by g sin theta we have to take, because net acceleration is nothing but g sin theta. That's it. There is no external agency. That is the logic. Okay. Upon solving and substitution, we have the formula that 1 by sin theta into root of what we write down, it is 2h by g. We can write down 2h by g. Similarly, at this condition also, you can write down as a what is the minimum initial speed that we need to project, they will ask. So u is equal to, simply we have to use the same concept, root of will get 2gl sin theta will get, and the time of ascent and as well as time of descent, both having the same to same expression, and there is no change in the even formulas also. Okay, time of ascent and time of descent both are going to be equal in this particular case. Anyways, let us try to consider the next case. At this condition, whenever object is releasing means the value of initial speed is nothing but u is equal to 0. You have to take care here. So let us try to write down here u is equal to 0. And what is the final velocity upon reaching here? That is the question what we need to remember here. Already we have a here, and I have to use the third equation of motion, and you can write down as the final velocity upon reaching the bottom is equal to under root of 2 into a net into L we can write down, which is equal to 2 into a net means what we write down here, 2g sin theta minus mu k cos theta into L we can write down in this case. And here this particular condition, what is the initial velocity what we need? So for this particular case, that means for the upward condition, what is the initial initial velocity? That initial velocity is given by u is equal to root of 2gl of sin theta plus mu k cos theta we can add up. And in these two cases, we have the time of descent this is, and we have time of ascent this is. So time of ascent, ta, time of ascent, very important formula. Time of ascent will going in upward direction, which is given by square root of 2 into L by g of sin theta plus, you can write as mu k cos theta as the first formula, and the time of descent is equal to given by root of 2L by you can write down as a g of sin theta minus mu k into cos theta we can take care. So by using these two formulas, one can decide the value of TA and TD. In the examination, they will give you ratio of TA to that of TD, and we need to solve the question for what? Mu k. Under such a condition, how to solve this particular case? Let us take the ratio. Then TA square by TD square is equal to, so in this case ta by d square dd square upon gg gets cancelled. Okay, then what we write down it is tan theta minus mu by, you can write down as tan theta plus mu. Upon making cos common, numerator denominator everything cancel, we will get. So by doing componendo and dividendo for this particular case, you can determine the value of mu of the system. Coefficient of friction can be computed in this particular case. Okay, now last case is that suppose semi or mixed intermixed condition is given like this. How to solve this particular case? Let us see. When the problem is given with the intermixing condition, so how, sir? Let us see. So this is the inclined plane what we imagine, and we have the imaginary block like this. We just kept something like an imaginary block. Now at this condition, object is just released from rest. Imagine that object is just released from rest. So u is equal to 0 at this condition. Now the length up to L by N portion, it is a smooth surface. This is smooth. And the remaining surface means 1 L minus L by N. This remaining surface, it is that means this particular portion. This particular portion is rough surface. Rough surface. Then so here at the intermediate point, velocity is nothing but v1 and final velocity is nothing but v. Let us try to prepare the equation for the distance of L by N. In this case, v1 square is equal to u square plus 2g into L by N sin theta. We have to write down along this. So on the block we have only one force, that is g sin theta, which will try to pull the down in the inclined direction. Next, we got the v1 square. Now question is that remaining distance, how much it travel? L minus of L by N. This is a remaining distance traveled on the rough surface. When object would like to travel on the rough surface, final velocity is nothing but v, you have to take here, and then we have to apply simply third equation of motion, v1 square minus v2 square, like this. That means v square minus v1 square is equal to, you can write down as 2g sin theta. You can write down like this. If it is a smooth surface into L by, but it is not smooth surface, na? So when object is coming in the downward direction, friction force action upward direction. Therefore, what we write down here, instead of g sin theta, we write down extra value subtraction mu k into cos theta. Already we have this formula, and upon solving both cases, we have the value of mu is equal to what we write out is n by n minus 1 into tan theta. Half of the length is given, that means L by 2 given. That means you can write down 2 by 2 minus 1, that means 2 tan theta you can write down. That is the value of mu. Okay, next one is what is the value of v1? Already we got the value of v1. And what is the final velocity? So upon solving this, final velocity upon reaching the bottom is given by 2g of sin theta plus mu k cos theta into n minus 1 by n into L. So by using this particular formula, one can decide the final velocity and intermediate velocity, where the intermediate point is remembered for the position where smooth surface will be ends. By using all these cases, one can determine that the concept of inclined plane motion. And further, in the examination, sometimes there is a chance to ask a question that if the plane was kept on the lift, like that, inside the lift, or it is moving a horizontal, moving in vertical. Different type of cases are given. In all cases, imagine that the block is relatively rest. Okay, so let us see the next case. So